A student emailed me asking for help preparing for the lab manual discussion board and the quizzes, and then of course the test. This video will give you some ideas on how to pull the lab manual and text materials together. When you go to the weekly lessons, the first thing to notice are the sections covered and the learning objectives for the week. These are the objectives you'll be tested on. Their sections in the text are identified as well. So for section 2.1, I want to concentrate on increasing and decreasing functions, and behavior of a polynomial, graphs of a polynomial, finding extrema or maximum values and minimum values of polynomials, and performing polynomial long division. Reading the appropriate section in the text introduces the vocabulary to understand the learning objectives better. In section 2.2, I will want to concentrate on sketching a polynomial from its equation, writing equations of polynomials from given information, writing the equation in something called root form, and using a graphing utility to find zeros. We know that you can't use a graphing utility on the test, but these types of questions are important to get a better understanding of polynomials. The first thing I would do is read sections 2.1 and 2.2 in the text. In this video, I will just look through section 2.1. Note that I'm using Google Chrome browser, so the icon to click on the CDF file is hidden at the bottom of the pop-up. Using Firefox is much nicer, by the way. In section 2.1, I see polynomial functions and the vocabulary needed to identify parts of the function. It then goes on to discuss the characteristics of the graph of a polynomial and introduces the concept of end behavior and how it applies to a polynomial graph. Next, it defines local maximum and minimum values of a graph, extrema, and how polynomial functions behave in regard to their maximum and minimum values. Actually, max and min values are not new. We discussed the vertex of a parabola in the last unit. A parabola just has one max or min, whereas a polynomial of degree n has at most n minus 1 max or mins. Another term for extrema is turning points. This is mentioned in the lecture notes we'll look at later. Next, the book discusses increasing and decreasing functions with a rather intimidating definition. When you look through the weekly to-do list, you'll see more information on this topic, since the book doesn't do the greatest job and relies too much on the interactive graphs that are problematic. Next, it discusses x and y intercepts. These are nothing new. We've seen these before with other functions. These are where the graph crosses the x and y axes. The next section is on adding, subtracting, multiplying, and dividing polynomials. Adding polynomials is just gathering like terms, so this is prereq material, and multiplying polynomials is just distributive multiplication, so this is a prereq topic as well. Notice that the learning objectives just mentioned long division, so you know to focus on division. Now, clicking into the week 6 to-do list, I see a video and lecture notes on where a function is increasing and decreasing from a graph, and it says that the text doesn't do a good job of covering this. Note that this was a learning objective. This gives examples to help with pages 44 and 45 in the lab manual. The next lecture points out things to pay attention to when reading section 2.1 of the book and what not to spend time on. The next lecture gives examples to correlate the symbolic or equation form of a function and its graph, and shows that polynomials should be factored to easily identify their x-intercepts or zeros. This gives examples for the problems on pages 46 through 50 in the lab manual. Some of this lecture overlaps with material in section 2.2. The last lecture revisits polynomial division, but gives a bigger picture to use polynomial division to determine the factors of a polynomial. Assuming you use the practice homeworks to prepare for the quiz, one thing to try is to first print the entire practice homework to a PDF file. To do this, you must first bring up a problem in the homework and select the Question Help icon. Choose Print from the pull-down and then choose Print Homework Assignment. You can select Print and choose Print to PDF. This may look different on a Mac, but the functionality exists there. Save the file to refer to later. Looking at the 2.1 homework, numbers 1 through 5 are about the graphs of polynomials. This was addressed in the first part of section 2.1. Numbers 6 and 7 are identifying increasing and decreasing intervals. You would need to graph the polynomial with Desmos or Wolfram alpha to determine the intervals. For number 6, notice it's a quadratic polynomial. Number 8's polynomial long division. Numbers 9 and 10 are applications involving polynomials, but the same learning objectives still apply. Note that you don't even need to graph these functions, but can answer the multiple choice question based on knowing the y-intercept of the function, which is either the constant term or 0. For number 9, you can answer parts A and B by identifying the y-intercept of the polynomial function. For number 10, you can recognize this as a quadratic, and the maximum or minimum is at the vertex.